Alrighty, so what we're going to talk about here is 7.6 to 7.8 EP1. We're going to define nth roots, connect nth roots with rational exponents, and then define rational exponents. So as you look through this assignment, you're going to see some parts that say like defining nth roots and also connecting nth roots with fractional exponents and then defining rational exponents. Those are the parts I'm going to do in this video. And then the other parts, the feedback zone, is what you're going to do on your own and then upload, and I'm going to give you feedback on that. Okay? So defining nth roots, so we've got a few things here. First of all, it says if b squared equals x, then we say b is a square root of x. Okay, that's pretty straightforward. We know that to be true. If something squared equals a number, then we call that the square root. So there's an example here. We know that 4 squared, for instance, is 16. And so that means that 4 is a square root of 16. Okay, so that's a square root. We know what a square root is. And we can define other roots. For instance, if b cubed is x, then we know that b is what we call a cube root of x. Okay, here's an example. If you have, let's see, the example we have here is 2 cubed. Since 2 cubed is, that's 2 times 2 times 2, which is 8. Since 2 cubed is 8, we know that 2 is a cube root of 8. Okay, so basically 2 times 2 times 2 is 8. So since you're multiplying it by 1, actually 3 times, 1 times 2 times 2 times 2, that's a cubed root of 8. Okay, fourth root, same thing, right? b is a fourth root of x is the next one, b to the fourth, right? If b to the fourth equals x, then we would say then b is a fourth root of x. Okay, and continuing on, we could have b to the fifth equals x. Then we would say then b is a fifth root, etc. And so generally we would say that if b to the n equals x, so if you multiply b by 1 n times, so you're multiplying n b's by 1, then we know that b is an nth root of x. Okay, so that's what we define it to be. Okay, just going to check to make sure this stuff is in the screen, which it is. Okay, so we've got a square root. Basically, multiply it by itself, you get that number. Multiply it by itself twice. I know it seems like 3 times. It's actually 1 times 2 times 2 times 2. Anyways, 2 cubed is 8, then 2 is a cubed root of 8. b is a fourth root of x if b to the fourth equals x. So basically these roots are the inverse of the powers. So if you square something, how do you undo that? You take a square root. If you cube something, how do you undo that? You take a cubed root. If you raise something to the fourth power, how do you undo that? You take a fourth root. So in mathematics, we always want to have an inverse operation so that we can solve equations and figure out, you know, figure things out that we want to know. And so that's not that articulate, but that's why we've got nth roots. Okay, so our notation before we move on, a square root we designate like this. That's the square root. A cubed root, we put a little 3 there. A fourth root, we put a little 4 there. A fifth root, we would put a little 5 there. And an nth root in general, we would put a little n there. So that's our notation that we use. So from here, you're going to move into the feedback zone and do a little thinking about that. So I'm not going to go over 6, 7, and 8. So you can pause this video and work through some of those. And then we're going to come back with connecting nth roots with fractional exponents. Okay? So we're really trying to get a good sense of how to deal with all different kinds of exponents. Exponents are some of the coolest things when we look at exponential functions. We're going to have a good time doing that. and they connect to roots in this way. Okay, so let's look at number 9. It says, use properties of exponents to simplify the following. We have 2 to the 1/2 and it's squared. So we should remember that if you have a power raised to a power, you should multiply those two things. Let's see, which color was that this year? That is the orange rule. Basically, when you have a power to a power, you multiply those. So this should be 2 to the 1/2 times 2. But of course, 1/2 times 2 is simply 1. So this ends up being 2 to the 1st, which is 2. Okay? 3 to the 1/2 squared, same thing. That should be 3 to the 1/2 times 2, which is 3 to the 1, which is 3. Okay, 4 to the 1/2 squared. That's just going to be 4 to the 1st, which is 4. And so we can recall that if we have something squared equals a number, then we say then b is a square root of that number, right? If something squared equals a number, then that thing that we squared is the square root of that number. But that's what we have here. We have 4 to the 1/2 squared is 4. We have 3 to the 1/2 squared is 3. We have 2 to the 1/2 squared is 2. So that basically means that x to the 1/2 has to be the square root of x, right? When you square the square root of x, you get x. When you square x to the 1/2, you get x. Again, if something squared equals x, then that something has to be the square root of x. But here we are showing that when you square 4 to the 1/2, you get 4. So 4 to the 1/2 must be the square root of 4. Wild, okay? The most important thing there is that x to the 1/2, that's another way to write the square root of x. We just used the orange rule, this power of a power property, to show that this would make sense. And so it sure looks like x to the 1/2 power actually means the square root of x. Okay, well let's see what would happen if we had something raised to the 1/3 power. Okay, so this is number 10 now. Okay, so number 10, we have 2 to the 1/3 cubed. Let's write it out just for fun. That would be 1 times 2 to the 1/3 times 2 to the 1/3 times 2 to the 1/3, right? Because that's what cubing something means. It means multiply it by 1 3 times. So then we can use, I believe it is the red rule that says we should add these exponents, add the 1/3. So we get 2 to the 1/3 plus 1/3 plus 1/3, but 1/3 plus 1/3 plus 1/3, a third plus a third plus a third, is 1 whole. So that's just 2 to the 1st, which is 2. Interesting. Okay, so again, we cubed that thing, we got 2. Now, if we did 5 to the 1/3 and we cubed that, we could use the orange rule in this case and multiply these exponents. We get 5 to the 1/3 times 3, which is 5 to the 1, which is 5. Okay, so again, if something cubed equals a number, then that something, b, must be a cube root of that number, of x. So again, we have something cubed equals 5, we have something cubed equals 2, so that means that something in there must be the cube root of 2. And this something right here must be the cube root of 5. So basically what we have shown is that x to the 1/3 must be the cubed root of x. Okay, so let's write that up here. X to the 1/3 has to be the cubed root of x. Okay, great. So we've just shown that with some properties of exponents, and it wouldn't be hard to finish out the rest of this and guess that x to the 1/n is actually equal to any nth root of x. Not hard to show. That's true. Okay, so x to the 1/4, that's the 4th root of x. X to the 1/5, that's the 5th root of x, etc. So you're now going to move into that second feedback zone and complete numbers 12 and 13. And maybe pausing this video and seeing if you can finish those off. And then we're going to continue on with defining rational exponents. Okay, I'm just going to double check that my video is still going. So I'm going old school here. We're 9 minutes in, not too bad. Okay. So all of the exponents that we've looked at so far to connect to roots have been to the 1/2, 1/3, 1/n. So what happens if we change that upper number? So the question is, what is x to the m/n? So this is a rational number, right? An integer over an integer, so m over n. What would that mean? So what we know is that x to the m over n could be written as x to the 1 over n all to the mth power. It could also be written as x to the m to the 1 over n power. Now, this is actually like the reverse of the orange rule, because what the orange rule says is if I have a power to a power, multiply the powers, right? But 1 over n times m, that's actually m over n, right? This would just be m over n, because this is actually m over 1, so you multiply straight across, that's m over n. So it's kind of like using the orange rule to break it apart. But this would work the same way, right? Because multiplication goes either way. 2 times 3, 3 times 2, same thing. I think that's commutativity, I want to say, of multiplication. So I could write x to the m over n either way. Okay, well now let's use what we know. We know that x to the 1 over n is the nth root. So this is actually the nth root of x, all raised to the mth power. I'm going to write that out in words. This is the nth root of x raised to the mth power. Okay, now what about this one? Okay, well, order of operations tells me that I should do the thing inside the parentheses first. So this is x raised to the mth power, right? X to the mth power. But then again, raising something to the 1 over n is the nth root. So it's actually the nth root of x to the m. So we're going to say this is the nth root. Actually, no. We're going to do the other thing first. Just to be clear, we're going to say x to the mth power, then nth root. That's really not the clearest way to write it, but I just want to, the important thing here, there are two important things. Okay, the first important thing is that when you see a fraction like m over n, which we're not actually going to see m over n that often, we're going to see something like 2/3 or 3/4 or 5/2 or something like that, the denominator means the root. Denominator is the root, and the numerator is the power. So when we see a fractional exponent, there's a root and a power. The denominator is the root, and the numerator is the power. And I've just shown you why. So the second thing that's important is that you can choose the order. Okay? You can do the root, then the power, or you can do the power and then the root. So either way is fine. You get to choose the order based on what's easier. And ooh, I just shook that thing quite a bit. But we're trying to think about what would be more efficient. So sometimes it's easier to take the root and then do the power. Sometimes it's easier to do the power and then take the root. So there are two things we want to remember when we see a fractional exponent, that the denominator tells us what root we're taking. So if this is a 3, we're taking a cubed root. This is a 4, we're taking a 4th root. And the numerator tells us the power that we're raising to. So we're raising to the 5th power, 8th power, 20th power, whatever it might be. And we want to know that we can choose the order that we perform these things. Okay, so let's see an example. I think the example that we've got is 16 to the 3/4. Okay, so let's see what we can do with 16 to the 3/4. And then I'm going to shut this all down, this handy dandy little video here, and let you do some more practice. So let's say we've got 16 to the 3/4 power. Okay, so there's two things that I'm going to remember. Okay, first of all, is that the 4 is the root and the 3 is the power. So this is the 4th root and the 3rd power. Second thing I'm going to know is that I can choose the order. I can either do the power first or I can do the root first. Okay, so let's see what this would look like. I could write this as 16 to the 1/4 cubed. That means I would do the root first, then the power. Or I could write this as 16 cubed all to the 1/4. That would mean that I do the power first and then the root. Okay, well, 16 to the 1/4, that is the 4th root of 16. 16 cubed, I do not know what that number is. And I don't have a calculator on me, and I don't want to find it. It's a big number. Maybe it's like, I don't know. I really don't know what that number is, and it's probably not worth me writing out, so I'm not even going to do that. Equals some big number, you know, 4th root of some big number. I don't know what that big number is without a calculator, and I don't want to go get my calculator, so I'm just going to leave it like that. Who knows what it is? But the 4th root of 16, I do know what that number is. 4th root of 16, I'm looking for a number that multiplies by 1 4 times. So I'm multiplying it 4 times. 2 times 2 times 2 times 2. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So this is 2. The 4th root of 16 is 2. That's 2 cubed, which is 8. Okay, so whatever this number is, I'm sure I would end up with 8 as well. But it just turns out that in this case, it is, I don't know if I'm out of the frame now. Let's check. It is, nope, I'm not. It is easier to take the root first. Okay, let's see an example where I can simplify it, just to make sure that you believe that it's okay to either do the root or the power. Okay? By the way, I should say that this is only true for positive bases. For negative bases, you have to be pretty careful. So this is definitely only true for positive bases. That means like it works for 16, but not necessarily for negative 16. Okay, let's say that we have, what can I do here? Let's say I do 9 to the 3/2. 9 to the 3/2. Okay, let's see if we can simplify that. So 9 to the 3/2. Basically, what I'm seeing here is I'm seeing a 2 in the denominator, a 3 in the numerator. That means I'm taking a square root and then cubing it. So I would say that this is going to be 9 to the 1/2 all cubed. 9 to the 1/2 is the square root of 9. That's how it's defined. And then I'm going to cube it. Square root of 9 is 3, and 3 cubed is 27. So 9 to the 3/2 should be 27. Now, if the numerator is bigger than the denominator, then you should end up with an answer that's bigger than the base because your power is bigger than your root. Let's see if we could do it the other way. So this, I did the root, then the power, which is often a nice way to do it. Now, what if I did the power and then took the square root? Well, I've got to do 9 cubed, unfortunately, which I'll do over here. 9 times 9 is 81. And what's 9 times 81? That's 9. And 9 times 8 is 72. So that's 729. So that would be 729. And then I would need to take the square root of that, because that's what a power of 1/2 means. And I'm sure if you plug in your calculator, the square root of 729 is 27. So either way, you end up with 27. So again, root of the power, denominator is your root, numerator is your power, and you can choose the order with which you do those. Okay? So there's a few other problems. I think it's maybe 15 through 18 that you're going to do in the feedback zone, and then you'll be done. All right, see you soon.